Okay, this first video is just going to go over the bell ringer for lesson 3 in unit 5. So before we jump into the actual lesson, here on page 47, let's just go through kind of this practice. Hopefully you've gotten a hang of it with doing the homework, but just in case, we'll do another practice. So this is a class of 40 students completed a survey on what pets they like. So I've drawn a diagram here with 40 students written at the top. The choices are cats, dogs, and birds, so I've created 3 sets. And then it starts to give us information. So everyone likes at least one pet. So I know nobody's going to be on the outside, and then I'm kind of done with that information, so I'm going to cross it off. 10 students like cats and birds, but not dogs. So 10 like cats and birds, but not dogs. So cats and birds is the overlapping here, but they don't like dogs, so they're over here. So that's going to be 10. 2 students liked dogs and birds, but not cats. So dogs and birds are over here, but not cats, means it's just this outside portion. So there were 2 of them. 12 students like cats and birds. So if I think about 12 students like cats and birds, there's already 10 in there, so that means that there are 2 to get us to 12 here in the middle. 8 students like cats and dogs. So again, cats and dogs would be this overlap here, and if 8 of them like cats and dogs and we already have 2, then that means we're going to have 6 more here. And then we just use our grand totals, right? It says altogether 28 students liked cats. So if you look at the cats, we already have 16, 17, 18 within the cat circle. And if 28 total liked cats, then 28 minus those 10 would leave us with 10 more out here. And then we'll do the same thing with dogs. 19 like dogs. So we take the dog circle, and there's already 10 in there, which leaves 19 minus 10, not... Sorry. Okay, birds. 15 like birds. So we've already got 10, 11, 12, 13, 14 in the bird circle. So that only leaves 1 out here for birds. Then we can answer those questions. How many people like cats, dogs, and birds? It looks like there in the middle, right? There were 2 that like all of the above, so we would say 2 people. The next one says if one person is chosen at random, what's the probability that person will like birds? So again, I'm just going to practice using the notation, but what's the probability, right? Somebody likes birds. We look over here. And really, we could actually use what they gave us. 15 students like birds, or you can look at here and see that there's 15 in the bird circle. So we would say 15 out of the total 40 students. And again, with probability, we generally simplify that fraction. So we could say 3/8. Or if you want to write it as a decimal, you could approximate that. Oops, too many zeros there. 0.375. Or in other words, 37.5%. So however you want to write it, again, just remember, any of it's fair game. D says, what is the probability a person chosen at random likes cats and dogs? So remember, and is just overlap. It says nothing about birds, so they can be included. Cats and dogs is this overlap right here, so there would be 8 of them out of the 40. So again, probability, cats and dogs, and we can either write and or use that symbol of intersection. That would be 8 over 40, or in other words, 1/5. Awesome. As we jump in today's lesson, we're going to use some examples in which you'll see a deck of cards, and that's just very common with probability. So I just wanted to be sure that we understand specifically what's in a deck of cards before we dive into that. So number 2 just is kind of a conversation. Fill in the appropriate numerical value to describe a standard deck of cards. So first of all, just understand that there are 52 cards in a standard deck, not counting the jokers. There's 2 colors. There's red cards and there's black cards. Half of them are red. Okay, so that's important we understand. Half of them are black. There are 4 suits. Hearts are red. Diamonds are red. Spades are black. I'm not sure why I was writing S. And clubs are also black. So there's your half red, half black. So if we take 52 and we divide it by those 4 suits, that leaves 13 cards in each suit. Okay. So using kind of that knowledge, it says how many queens are in the deck of cards. Well, there's a queen for each suit. So if there's 4 suits, then there's a queen in each suit. A queen of hearts, queen of diamonds, queen of spades, queen of clubs. How many red queens are in the deck? So if there's a red queen of hearts and a red queen of diamonds, that would be 2 queens. So when it uses language like this, it's just assuming we could identify how many. So using probability, A says, what is the probability of choosing a black jack? So we think about how many black jacks are in the deck of cards. Well, again, there's 2 black suits. So that means that there are 2 out of the 52 total cards that could give us a black jack. If we simplify that, we get 1 over 26, or again, you can write it as a decimal if you'd like to, or as a percentage. So not a super high likelihood there. The next one says, what's the probability of choosing a number less than 4? So if you think about inside a deck, how many numbers are less than 4? In each suit, right? You have an ace that represents a 1, and you have a 2, and you have a 3, and then you get to 4. So if you think about what's less than that, that would be 1, 2, 3, and there's 3 of those in each suit. So we would say ace, 2, 3, right, times 4 suits. That would be 12 cards that would be less than 4. Hopefully that made sense, out of the 52. So in this case, again, we would simplify to 3 over 13, or sometimes it's easier just to write it as a decimal than even to simplify that. We get 0.231. Okay.